Now that I've grabbed your attention with that below average pun, I'm going to address the topic in which you and I are here to discuss, and that is alternating current sinusoidal waveforms. These waveforms are a representation of the voltage output from sources such as electric or function generators as a function of time. The general motion of such waves can be observed here. The typical shape of a sinusoidal waveform can be seen in the right image, as the change in voltage polarity is represented by a symmetrical form above and below the equilibrium line. The reason this voltage polarity changes is due to the rotating magnet and its interaction with the stationary coils. We can observe this relationship on the left momentarily. The voltage produced by these stationary coils is proportional to the magnetic flux in the system, therefore at a maximum when the angle of the rotating magnet is at 90 degrees. The relationship between the angle of the coils and the rotating magnet is also described by the figure on the right. There are many facets of these alternating current waveforms that need to be considered when analysing them. The voltage is described by the amplitude of the wave. There are three types of voltages that may be referred to, and these are peak, peak-to-peak, and RMS voltages. The peak voltage is often referred to as the amplitude of the wave, whereas the peak-to-peak voltage is the sum of the magnitude of the positive and negative peaks. The term root mean square, or RMS voltage, is used in order to compare the functionality of AC voltage or current in respect to DC. This RMS voltage can be found by dividing the amplitude or peak voltage by root 2. We also need to consider the period and frequency of a wave when understanding them. The period is the term used in reference to the period of time taken to complete one complete cycle of the wave. This is inversely proportional to the frequency of the wave, which describes how many cycles of the wave occur within a given time period. These alternating current sinusoidal waveforms are often described in equations which are characterized by the individual facets of the wave that we learnt about previously. The typical form of these equations is shown here, where the leading coefficient A defines the amplitude of the wave, or as described before, the peak voltage. The frequency and the time of the waveform are specified by F and T respectively, and phi describes the phase of the wave in respect to a sine wave with no shift on the x-axis.